Sarah, your host for this topic, which is all about adding and subtracting rational numbers. In this topic, we'll learn when it's helpful to use a number's opposite, and when it means to add less than nothing to something. We will also see how subtracting rational numbers is different from subtracting whole numbers. Finally, we'll see what kinds of problems you can solve by adding rational numbers and what kinds of problems you can solve by subtracting rational numbers. As you've probably noticed, this whole topic is perfectly rational. So let's get this thing rolling, shall we? I'll see you all very soon.
Okay, so what are some types of rational numbers? Also, how is solving and subtracting these numbers going to be helpful? First, I'd like you to take a moment and think about what is a rational number and try to come up with some examples. So at this moment, I want you to get a piece of paper, write out your ideas of a rational number, and pause this video. Once you have your ideas written, replay. Okay, so what are some of the things you might have thought of as a rational number? Well, from all of our talk, I'm hoping that you saw the word ratio. And you knew ratio meant it had to look like a ratio. So you might have came up with 2/3. You might have also said, you know what, 5/5. And what is 5/5? That's right, it's 1. So we can see that we have some whole numbers coming now. So we have some fractions, which are ratios. We have some whole numbers. Some other examples can be decimals. Let's say 0.25. Wait, we've been talking a lot about percents lately. How can I rewrite 0.25? That's right, 25%. And isn't there another way that I can write both of these? That's right. It is 25/100. Wait, what did I just do? I wrote it as a ratio. So a decimal or a percent that can be wrote as a ratio is a rational number. So let's think about when this could be helpful to us. Well, the weather's been changing a lot, so maybe the temperature. You want to know how much it's changed. That might be a time where we're using some rational numbers. We could be adding, because maybe today it started out cold and it went up, so we could be increasing. Or maybe it started warm and a strong north wind came and it cooled it off, and it would be decreasing. Okay, so we're going to go ahead and skip to examples. I'll give you a moment while you do that.
Here are some examples of rational numbers. 1/2, 19/4, -21/5. What about -7/10? Is it a rational number? Yes, it is. -7/10 can be written as a fraction in the form (a/b), which means it's a rational number. What about 5 1/3? Is it a rational number? 5 1/3 can be written as the improper fraction 16/3, which is in the form (a/b). So it is a rational number. 9 9/100 is a rational number. So is -6 25/100. Whole numbers is a subset of rational numbers. Here are some examples of whole numbers. 0. 0 can be written as 0/1, which is in the form (a/b). 1, 2, 3, and so on. Integers is a subset of rational numbers. This subset includes the set of whole numbers. Here are some examples of integers. -1, -2, -3, and so on. -3 can be written as -3 over 1, which is in the form -a over b. Now that you've seen these numbers put into their categories, do you think you can do it on your own? A rational number is a number that can be written in the form a over b, or -a over b, where a and b are whole numbers and b is not equal to 0. You can also think of rational numbers as the whole numbers, fractions, and decimals you already know, and their opposites.
So ladies and gentlemen, a couple things. While you're watching the videos, make sure you're taking notes. If you need to rewind at any time to catch something a second time, please do so. I want to focus on the rational number for the moment. Remember, the rational number has the word ratio in it, and we see ratios, both positive and negative. We do have the little disclaimer where the b, the denominator, cannot be equal to 0, but you are already aware fractions cannot have 0 in the bottom. So as long as our b value is not 0, we're in good shape. Also, it says, can you think of rational numbers as whole numbers? Fractions and decimals you already know. We talked about that a few seconds ago, plus they gave you some more examples. And their opposites. That's one thing I didn't do in the intro, was to show you those opposites. But remember, 5 has an opposite of -5, or -5/10 could be +5/10. So I'm going to ask that you take a moment and you copy down the definition for rational numbers. Make sure that you accentuate the word ratio, so that that's always a clue for you, because that's a requirement for a rational number. And then I also want you to write down the examples for the whole numbers, the integers, and the rational numbers, so that you see how those subsets have built in order to include all rational numbers. So go ahead and pause the video at this time. Okay, so hopefully you've gotten down your notes and you took those examples. Now you're going to be asked to take and place each one of these numbers into the category. Is it a whole number, an integer, or a rational? You want to get it into the most specific case. So let's pick 0. I'm going to work 0 with you. Yes, 0 can be written as a rational number. I can write 0 over 1. 0 is also under the integers, but 0 is also under the whole numbers, and that's the most specific. So I want to put 0 under here. I'm going to work a second one with you, just so that we're getting clear on what I want you to do in a moment. Let's take a -125. Well, is a negative ever going to be a whole number? No. Can it be an integer because it's an opposite of a whole number? Yes. Can it be a rational? Yes, because if it is an integer, it is a rational number. I'm looking for the most specific case that it can be. I'm going to place it under the integers because that is the most mirroring category. So it's going to be -125. So I'd like you to take a moment, and I would like for you to filter all of these numbers into these 3 boxes on your paper. Go ahead and pause while you do so. Okay. So hopefully you've done this and you're matching your numbers up to mine. Now let me know if I make a mistake, because you know that does happen. But I have my whole numbers listed as 0 and 13. Those are the most specific cases I can get them in. My integers, I have -125 and -7. So then I come over to my rational numbers, and I have, let me set all the cameras right, sorry guys. I have 1 and 9/10. Wait, how can that be? Oh, that's right, 1 and 9/10 can be written this way. And then to make it a mixed number, improper fraction, that would be 19/10. It can, in fact, be written as a ratio. Same with 1 and 1/6. Wait, this -1/10 Are we sure that it doesn't belong in the integers? Did I make a mistake? No, I didn't. You guys have got me. This is going to be over here as a rational because it's a decimal. Integers are only whole numbers and they're opposite. So -1/10, -2 1/4, 2/3, and -3/4 are all rational numbers.
To which sets of numbers does -1 and 3/5 belong? Whole numbers, integers, or rational numbers?
Well, let's see. Is it a whole number? That's correct. It is not. For two reasons. One, it's a negative. And second, 3/5, immediately we know that that is going to be it's not a whole number. Is it an integer? Well, it is negative, but is it a negative whole number? Sorry, opposite of a whole number being a negative? No. So the only one that it would fit in is into rational numbers. So let's check to see if we're correct. So let's go ahead and hit the show correct answer. We were correct. Thank you.
The absolute value of a number is its distance from 0 on the number line. The absolute value of a positive number is the number itself.
So in this case, the absolute value is 2. All that means is that it is 2 units away from 0. So we have 1, 2. It is 2 units away from 0.
The absolute value of a negative number is the opposite of the number.
If you'll push here. So in this case, we're saying -1 4/10 is equal to 1 4, or 1 4/10. Notice it's positive because the only thing we're talking about is how many units from 0. We're not describing direction. A negative simply describes direction. It tells us we move to the left. This, when you take the absolute value, is just saying I am this many places away from where I started. In this case, 0. So you're 1.4 units from 0. Earlier, if you see my marks, we were 2 units because we had the absolute value of 2 was 2. Okay, so go ahead and let's watch this third piece. Let me just scroll down a little. Thank you, sir.
Two numbers that are opposites have the same absolute value.
So, what he's saying is if I have 3 halves, the absolute value is going to be 3 halves. If I have -3 halves, the absolute value is still 3 halves. And that's because I'm only talking about how far from 0. Again, the negative only tells me the direction. This just tells me that I'm 3 halves to the left of 0. This just tells me I'm 3 halves units away.
Complete each statement with the symbol that correctly compares the absolute values.
I know any negative number is less than any positive number. So, -4 is less than +2. But when a negative number is farther away from 0 than a positive number is, like -4 is farther from 0 than +2. Something seems bigger about the negative number. I guess that something is the absolute value. The absolute value of -4 is greater than the absolute value of 2. Isn't it funny how something that's less can be bigger?
That didn't work out so well for us, did it? But let's look at these ones for the moment. So what she's saying is you're going to look at that number line. And -5 is over here, and 3 is over here. And we know -5 is definitely smaller than 3. But if I take their absolute values, what happens? Well, the absolute value of -5 is now 5. The absolute value of 3 is 3. So, which one is going to be greater? 5. So I'm going to put the greater than sign in. So I want you to try it for these next two and see what you come up with. So go ahead and pause at this moment. Welcome back. So while you were gone working on your math, we got the technical difficulty handled. But before we move on to that, why don't you take and compare your answers? Did you find that the absolute value of negative 7 and 6 tenths was 7 and 6 tenths? And the absolute value of 6 was 6. And that 7 and 6 tenths is in fact larger than 6. And did you agree with me on 1 is less than 3? All right then. So let's go ahead and try these ones real quick on your own and then come back and see what we find out. Okay, so ladies and gentlemen, it takes a little bit of thinking about these fractions, but 1/2, the absolute value of negative 1/2, is going to be greater than the absolute value of negative 1/4. Then they did a little trickaroo on us, didn't they? They gave us 2 equals, because the absolute value for both 3 and 1/10 and negative 3 and 1/10 is equal. Then we look here and we go 4.5, the absolute value would be 4.5. And the absolute value here, well, that's going to be 9/2. And if I simplify that, I in fact get 4 and 1/2. Okay, thank you. Let's go on to the next one.
You can use positive and negative rational numbers to represent changes in real-world quantities. 2 changes represented by opposites result in no change.
Time to get another haircut.
Opposite changes result in no change.
Okay, so ladies and gentlemen, what we saw here is her original length of her hair was 1 3/4 inch longer. She had 1 3/4 inch of her hair removed. So that gave her short hair. Then we see over here, her hair grew back out. So ladies and gentlemen, after that month goes by and her hair has grown 1 3/4 inch, what the gentleman is saying is there's no change in her hair length from the time she previously got it cut to this time when it needs cut again, because these have canceled each other. Let me show you another way. Well, they should say they zeroed each other. And it's called the zero property of integers, technically. If I have $5 in my pocket, so let me put the money sign on here. And you know I like money, so I always talk about money. And I'm going to go to Starbucks, and I'm going to buy my coffee, and it happens to be $5. Well, they're going to charge me 5. It's going to be a negative 5. So I get 0. Now, I do have a cup of coffee, so that's worth more than $5 to me. But I started off with a positive 5. Then I spent 5, so that's a negative 5, and it results in a $0 left in my pocket. Another way to think of this is if we're talking temperature. If the temperature starts off at 10 degrees Fahrenheit and it climbs 10 more degrees, I am now at 20 degrees. But what happens when the wind blows and that winter wind is coming in and it drops it 20 degrees? So it's a negative 20. It results in 0. So you can see where a number and its opposite are going to cause a 0 situation. Go ahead and play. I'll erase this real quick. So we saw as it was heating up,
Opposite changes result in no change.
we saw as it was heating up, it increased 20 degrees. Then as it cooled off, as the sun went down, it decreased 20 degrees. This results in zero change. We're back to our original spot. Go ahead and play.
You need to save some of this allowance for the future, like for college. Uh-huh. Saving for the future. Got it. Yeah, I got a new graphic novel and some lipstick and... You know something? Saving for the future sure is hard sometimes.
Okay, so we saw.
Opposite changes result in no change.
He keeps interrupting me, doesn't he? So we saw that she deposited $10 into her account. And then she really had to have this. She couldn't wait. She had to break the poor little piggy bank and take the $10 out. So then what was left in the piggy bank? Nothing. Zero. Because she has taken out the money she had put in, the equal amount. That she put in was the equal amount she took out. Okay.
Write a positive or negative number to represent the change described in each situation. Describe the opposite change in words and with a number.
Okay, so it's asking us to write a positive or a negative number to represent the change that's being described in the situation. So they're saying, this situation, you climbed up 7 stairs. Well, up is increasing, right? So you're going up 7 stairs. The opposite would be, I climbed down 7 stairs. The opposite of a positive 7 is a negative 7. So I would like you to take a moment and go ahead and do these next 2. Go ahead and pause now. Okay, thank you for coming back. Hopefully you used the restroom or got a drink, whatever you needed, because I know it's been a little bit of time this evening. Let's compare our answers. The car used 9.2. They used, so that was taking away. So they have a negative 9.2. Well, the opposite of negative 9.2 or negative 9 and 2/10 is a positive 9 and 2/10. And then they rewrote the sentence here as you put 9 and 2/10 gallons of gas in the car. Let's look at the next one. If a submarine descends, ooh, a key word here, descends. Descends does mean go down. Make yourself a little side note because that's a vocabulary word you're going to see and it's going to trick you. Descends means down. So it's descending 3/8 of a mile. So it's a negative 3/8. So they came up with that it needs to be a positive 3/8. Well, if the submarine went down, they're going to say the submarine rises 3/8, or they could have given you a new vocabulary word, and they could have said ascend, which also would mean going up or rising. So these are 2 key vocabulary words that you may want to add to your word banks just so that you know what they mean when you do come across them in a story problem. And hopefully you came up with these particular answers. Okay, so ladies and gentlemen, we still need to work on some more vocabulary. I just talked about those word banks of ascend and descend, so that's a vocabulary you're familiar with. Well, we have some math language we also need to become very familiar with, so that when I'm using these terms in the classroom, when I'm talking with you, you know what I am asking. So a rational number. We talked about this at the beginning of this video, and it can be written in the form of a ratio. Remember, I've asked you to circle the word ratio when you see that so that you know you're talking about ratios. And they can be written as A over B or negative A over B, so long that B is not equal to 0. So if we come over here, we see some examples. We see negative 2 and 1/10 can be rewritten as negative 2 and 1/10, or we can put it as an improper fraction of negative 21 over 10. So that we can also graph. Oh, I see, they have some different things up here graphed for us. So we can see that right here is where that would fall on the number line. We can also see the plain old number 3 is rewritten as a ratio as 3 over 1. So anytime you see a number that has no denominator, but it's a whole number, you know that you can put it over 1, and it becomes a ratio. So let's look at the absolute values that we've talked about. Remember, absolute value is all about how far from 0 you are.
The absolute value of a number is its distance from 0 on the number line.
If you'll click this dot here for me. Thank you. Okay, so ladies and gentlemen, we see that the absolute value of -1 is 1 because it's only 1 unit. Let me physically travel that 1 unit. It's only 1 unit away from 0. 3, the absolute value is 3 because if I travel, I am 3 spaces away from 0. That is all absolute value tells me is the positive value of the number of units I'm away from 0. So how far am I from 0? Go ahead and scroll down a little. Okay, and go play that, please.
Opposites are two numbers that are the same distance from 0 and in opposite directions.
Kind of a give me. -3 is the opposite of 3. Also, the absolute value of -3 is going to be 3 because it's 3 spaces away, just as 3 is 3 spaces away. So if I combine these two, I'm going to meet at 0. Remember when we did that a little earlier? I had 3 and -3. I got 0, and that's because they're each 3 spaces away from 0. So if I move towards 0, 3 from each direction, I will arrive at 0. Okay? So ladies and gentlemen, at this point you should feel comfortable to come into class and work on the assignments for 4-1. We've talked about the rational numbers, we've talked about absolute values, and we've talked about opposites. If you have any questions, please re-watch this video. I'm also asking that you write your questions down so you can ask very specifically what your question was. I was uncertain of this. Don't come in and say, I didn't get it and I don't know. Because I don't know what you didn't get or what it was you don't know. So make sure you're writing down the exact thing you want me to clarify. Write down the example I provided. That will help me know specifically where to help. Again, this is here for you to watch as many times as you need. Fast forward through things you got and rewind through the things you need to watch. Also, in case you're wondering who I'm talking to when I say fast forward, pause, play, it is my husband who is helping me create this very first video for our flipped classroom, and I'm excited about this. And as we go, we're all going to learn. Thank you.